going to go over 1b. Okay, so you can see, and this didn't render super well, so let me pull up. You can see just by writing a few out that, okay, it looks like t to the k, the closed form of t to the k is going to be 2 to the k. You can also tell that just by looking at this, it's like, okay, it's going to be 2 of whatever it was before, and it starts at 1, so you just keep doubling 1, you know, that it's 2 to the k. So, okay. To prove it, in the induction step is like what I'm going to go over, because that's like the trickiest part. The rest of it is like just kind of redundantly stating what you just did, and then the first part, the base case, is just like writing kind of just what they give you. So this is the part that makes you think. Okay, so our proof is only going to apply to numbers over 0. We are hypothesizing that t to the n equals 2 to the n, and then in your base case you would prove that that's true for like a number up to k. So you could just write t to the 1 equals 2 times t to t of 0, and then it would be 2, and that, boom, that would be proven. So you do that, and we wind up with this. T to the n equals 2 t to the n, or t of n minus 1 equals 2 to the n. I'm saying t to the n and then 2 to the n it's easy to just mix up words there. Anyway, all right, and we went over this before. It's true for n less than or equal to k, and now we're proving that it's true for n greater than k. And ultimately, this is what we want to wind up with. So we're going to start with what they gave us in their recursive formula, and we're going to plug in k plus 1 for k. So now we have t of the k plus 1 equals 2 t k plus 1 minus 1, and we just simplify and we get t of k plus 1 equals 2 t to the k, t of k. Whew. All right, so this t of k that we have right here, we can plug that in because t of k, like t up to a point of k equals 2 to the k. So we can plug in t of k 2 to the k. So after we swap out t of k for 2 to the k, it's also clear. So t of k plus 1 now equals 2 times 2 to the k. So if you multiply anything by itself, you just can add to their exponent, and that's exponents. So when we simplify, we've reached the end of where we need to be in our proof, in our inductive step. So that one is pretty similar to the one before, and that was how I proved it.